In this tutorial, you'll see how to start the cell tracking wizard, how to adjust the settings used to create the model, and how to analyze your data samples with the model created. The goal is to identify the location of the parent population and then confirm a few other settings. Once these simple decisions are made, the wizard constructs a model that accurately analyzes your cell tracking samples. Let's get working. Start ModFidLT and click the File button on the toolbar. Navigate to the folder called Proliferation under the ModFidLT Samples folder and select nonprol.fcs. This is the control file locating the parent population. Choose FL2 height log as the parameter to analyze. Click OK. We won't define any gates for this example. From the Analysis menu, click the Cell Tracking Wizard and choose Create or Edit Model. Tabs across the top of the dialog are labeled with the categories of model settings. The Start tab options let you create or edit a model and also provide an alternate path to open a data file. We already opened the file we want to use, so let's look at the Parent tab. This displays your data file so that you can define the parent population peak location. The program automatically positions the red cursor over the highest intensity peak that it finds. You can click the red triangle and drag it over the center of the parent peak if necessary. Or you can edit the parent channel. For this example, the peak is around 1529. This tab allows you to lock the standard deviation of the Gaussian component used to model the parent population. This option is most useful for samples in which there is a great deal of proliferation. In these cases, the parent population is often difficult for the model to resolve, and the modeling process may broaden the SD of the parent too much. For this example, we'll leave it unchecked. Click the Generations tab. Here you can review and edit the number of generations to model. Normally, you will not need to make any adjustments here. There are two variations for modeling the generations, standard and floating. In the standard mode, the mean position of the Gaussian for each generation is dependent on the position of the parent generation. Each generation will be at a location that is half the intensity of the previous one. Floating allows the mean of each generation to be computed independently. This option provides greater flexibility to the model and will work well for samples with visually distinct generations. The floating option is not recommended for samples where generational boundaries are not apparent. For our example, we don't need to adjust any additional settings. Click the Analyze button. Percentages and means are reported for the parent and each of the generation populations. You'll also notice a wizard toolbar. The first button lets you open and analyze a data file in a single operation. The second redisplays the Cell Tracking Wizard dialog so that you can edit the model. And the third lets you exit the wizard. These options are also available in the Analysis menu, Cell Tracking Wizard pop-up. After setting up the model on a non-proliferating control, open and analyze the samples collected at subsequent time points. For this tutorial, we have one proliferating sample. Click the first button on the wizard toolbar. Open the next file, prol.fcs. Click OK in the Analysis Setup dialog. As soon as the file is loaded, the wizard analyzes it and new results are displayed. We now see some interesting distributions and the percentages for each generation. Also reported are some indices to help quantify the extent of proliferation in the sample. More information on these results can be found in the ModFidLT user guide accessed via the Help button. You may want to explore several other options in the wizard found in the Other tab. Click the Edit button on the wizard toolbar. On the Start tab, the wizard has switched from Create to Edit the current cell tracking model automatically. Click the Other tab and enable the Background option by clicking on it. This will subtract debris in the sample. Click the Asymmetric Cytokinesis option. This allows interpolation along the background rectangle to set the standard deviations for each of the generations. It yields an analysis result called Division Error Index that quantifies the degree of error the cells made in dividing. The other edit field in this group defines the starting generation for true proliferation. This value is used in the calculation of upper generation proliferation index and the precursor frequency. For a reference on the use of precursor frequency, please contact us. Click the Analyze button. The sample is analyzed again using these selected options. When you have finished with the cell tracking wizard, click Quit on the wizard toolbar. The wizard will ask you to confirm, and just click Yes to exit. The cell tracking wizard is a tool designed to allow you to easily analyze samples prepared with cell tracking dyes. It shows categories in tabs that allow you to describe your samples and choose options to appropriately model your data. Thanks for watching.